This is the third page from that review. And on the third page, it's mostly doing angle of elevation and depression. So like the first one right here, it's talking about a bunny slope at a ski resort. It says that the resort's 1,367 meters long. So here's the slope. Basically, it's the hypotenuse of the triangle. 1,367 meters long. It says the vertical drop, vertical goes up and down, 200 meters. It says calculate the angle of depression. So here's your angle of depression. That's the one you're looking for. And then round to the nearest tenth. So from this angle over here, this would be your opposite. And that's definitely your hypotenuse. Opposite and hypotenuse, that's sine, according to SOHCAHTOA. We don't know the angle, so we're going to do the inverse sine. Opposite is 200. Hypotenuse is 1,367. And that's what goes into your calculator to find your angle. So inverse sine, remember to be in degree. 200 divided by 1,367. Make sure I close that parentheses because I'm not sure if it's going to change the answer. Okay, this is the same. 8.4 degrees. That's the angle of depression for that slope. That bunny slope. Next one, this is, you can see in the drawing, angle of depression. And as I mentioned before, angle of depression, you can treat it like angle of elevation. And you can see it from down in here. Says you see a landing spot, angle of depression is 52. So I put it down here as angle of elevation. The ground to the landing spot is 4,200 feet. You can see it's already in the drawing for you. What is your altitude? Altitude is the one that goes straight up like that. So if we ignore what's happening up here, from that angle, this is adjacent and this is opposite. So opposite and adjacent, we're doing tangent for this problem. This time we do have the angle. The opposite's still going to go on top because of that SOHCAHTOA. Adjacent's going to come down here to the bottom. On this problem, x is on top. That means you're going to multiply. So 4,200 times tangent of 52. Oh, sorry, 5,357.8. 5375. 5375.8. And that's feet. Number 15. Find the height to find the height of a tall palm tree, you use a transit to measure. Transit's this thing. I didn't even know what a transit was, but if they're using something to measure and the drawing shows the little dude using that, that's got to be the transit. So he's using a transit to measure the angle of elevation to the top of the palm tree. The angle of elevation is 29 degrees. The transit is 5.8 feet tall. So if you think about it, it's 5.8 feet off the floor. So you're going to be adding 5.8 feet to your answer. If you find the leg over here on this right triangle, you're going to add 5.8 feet if you want to get all the way to the floor. And you set it up 80 feet from the base of the palm tree. So going this way, 80 feet from the base, that does not get affected by those 5.8. So now we've got the problem set up and we're looking for how tall is the palm tree. So we're going to find this and then we're going to add 5.8 feet to it. From that angle, 80 is adjacent and x is your opposite. And opposite and adjacent is tangent. We have the angle. opposite goes on top, adjacent goes down to the bottom. This is multiplication because the x is on top. So 29 times tangent 29. Oh, wait. Duh. Sorry, still half asleep. That should have been an 80. Ugh. Oof. So it'd be 80 times the tangent of 29. 44.3. And then don't forget, that would be here. So we still need to add the 5.8 to get to the ground. Now it's 50.1. Number 16. This is those geometry mean problems. This one's kind of strange. I'm going to replace it with one more like what we did in class. So I'm going to show that underneath here once I do this problem, but I want to show you how it works. So remember the geometric mean was the one where this side, the altitude that we were looking for equaled the square root of these two numbers multiplied together. Well, the opposite of, or the inverse of square root is to square the numbers. So this can give you 9 equals, and then you would square this side, 18a. Then you can divide both sides, and you get a is 1/2 or 0.5. So that's how you would work the problem out, because the geometric mean was this equals the geometric mean of these two numbers together. But I'm going to replace that with another problem that's going to be closer to what we did in class, because that's only fair. So if I have something like this, let's say this is my altitude this way, it's going to be where I give you like both sides over here. And I could ask you either for this side, the altitude, or this side. And just to remind you, if I wanted to find the ones on the outside, I need the entire hypotenuse. So you're going to have to add those pieces together. And to find x, for example, it's the geometric mean of the side closest and the entire hypotenuse. If I want to do the altitude, it's only the left side and the right side, or the two smaller parts, but it's still the geometric mean of those two numbers. And if I want this side, just like we did with x, it's the geometric mean of the one closest, which is the 8, and then the entire hypotenuse. And so you can work the problems out, and that would be the altitude or the leg or this leg over here. So like on this problem, square root 4 times 12 be 6.9. This one in the middle, square root 4 times 8, you get 5.7. And then this one, square root 8 times 12, you get 9.8. So this is going to be what you're going to expect to see on the actual test, because this is what we did during class. But this part over here, hopefully this makes sense and it's not too difficult, because it may come up in your next class.